Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 33, going from equations to inequalities. And a couple things we're going to be looking at today is, one, you should be able to understand that an inequality with a numerical expression is either true or false. It's true if the numbers calculated on each side of the inequality sign result in a correct statement, and it's false otherwise. So basically saying 2 is greater than 1, hey, that's true. Saying 2 is, I should say, oh boy, that's funny. 2 is less than 1 is false. 2 is greater than 1 is true. And of course you get into the equal than, greater or equal than, less than or equal than, you get into equal signs, all that good stuff. Today we're going to look at understanding an inequality. Understand that solving an inequality is answering the question of which values from a specified set, if any, make the inequality true. So they're going to give you some options. So they might say a plus 1 equals 3. Well, you know a has to equal 2. So they might give you a set that says, well, 1, 2, 3, and 4. And you would know, hey, 2 is the only one that's true in that set. So let's go ahead and jump right into the examples, and we'll get started. All right, which of the following numbers, if any, make the equation or inequality true? So we have a set of numbers here. When you have those brackets like that and there's numbers inside, separated by commas, that's called a data set. That's a set of numbers. And so we're looking at 0, 3, 5, 8, 10, and 14. So we have 6 different numbers that we're going to be checking as we look into these inequalities. All right. So we have m plus 4 equals 12. Basically what we're going to do is plug in each of these numbers to see if it would be true, right? So m plus 0, or excuse me, m plus 4 equals 12. If m is 0, we'd have 0 plus 4 equals 12. That's not true, so can't be 0. If m was 3, it'd be 3 plus 4. That would equal 7, so it would not equal 12, so that doesn't count. If m was 5, we'd have 5 plus 4, which would equal 9, which would not count. 8 plus 4 does equal 12, so 8 is true. 8 makes that statement true. 10 plus 4 is too high, that's 14. 14 plus 4 is too high, that's 18, so that also does not equal 12. So 8, in this case, is the only answer that makes that statement true. And we could probably guess that there would only be one statement, or one number, I should say, that would make that true, because there's an equal sign. So something plus 4 equals 12. Well, there's only one number plus 4 that's going to give us 12, in terms of positive numbers anyway. So, part B, we're still looking at the same data set, the same set of numbers. Part B becomes a little bit more interesting, because it says m plus 4 is less than 12. So we're going to plug in all these numbers and see which ones, if you add 4 to it, would still be less than 12. If 0 plus 4 is 4, 4 is less than 12, so that is true. So 0 would be one of the numbers that would count, right? 3 plus 4 is 7, so 7 is less than 12, so then 3 does make that statement true. 5 plus 4, if we put 5 in for m, 5 plus 4 is 9. 9 is less than 12, so 5 counts. And now we get to 8. 8, we already know 8 plus 4 is equal to 12. So it's not less than 12, it's the same as 12, so 8 doesn't count. And then as we get larger, anything plus 4 that's larger than 8, so if you take 8 plus 4, 9 plus 4, 10 plus 4, any numbers bigger than 8, and add 4 to them, they're going to be greater than 12. So we know that 10 and 14, they don't count. They're not going to work. Now you could still plug them in to check, right? 10 plus 4 is 14, 14 plus 4 is 18, and so neither one of those count. So our data set here is 0, 3, and 5. Those are the only numbers from this set that makes this statement true. Okay? So how does the answer to part A compare to the answer to part B? Well, in part A, there is only one possible answer. In part B, there are multiple answers. That would make that statement true. So that's the big thing there. Here we have an equation because it has an equal sign. Here we have an inequality because it has a greater than, less than, or equal sign. Or I should say greater than or less than sign. And so in this one, 8 is the only possible answer. In this one, 0 and 3 and 5 are possible answers, and that's only if we're counting the numbers in the set. There are a whole lot more answers that would also be correct. Okay, let's continue moving on here. F minus 4 equals 2. We're still looking at the same set, so I'm going to write them over here. 0, 3, 5, 8, 10, and 14. F minus 4, any of these numbers over here, none of them would work. And here's the deal. Something minus 4 to equal 2, well, if I want to find out what F is equal to, I can add the 4 to both sides. Plus 4, and you're going to get F equals 6. So, having said that, the only thing that would make it true, and I left it here because I wanted to go through this one fairly quickly, but 6 minus 4 equals 2. So F has to equal 6. None of these numbers in the set are 6, so none of the numbers are correct. 6 is the only possible true solution. Okay, part D. F minus 4 is greater than 2. Okay, so we could plug in all of these numbers up here, one at a time. That's one way to do it. That's not wrong. It's going to take a little bit longer. We can also use our number sense. So we already looked at up here in part C, we said, okay, 6 minus 4 is equal to 2. So we want something that you can take away 4 and it's still going to be bigger than 2. So if 6 minus 4 is 2, then 7 minus 4 would be 3, right? So anything bigger than 6 would still make this true. Anything bigger than 6. So it can't be 6, but it could be 7, 8, 9, 10, 11, 12. You take any of those numbers and subtract 4, and your answer will still be larger than 2. So if we look over at our data set, there are 3 numbers that are bigger than 6. And that would be 8, 10, and 14. And it makes sense, right? Because if you look at 5 minus 4 is 1. 1 is not greater than 2, so that doesn't work. Nothing smaller than 5 could work. You could plug in these numbers and still check them. 8 minus 4 is 4, so 4 is larger than 2. 10 minus 4 is 6, 6 is larger than 2. 14 minus 4 is 10, 10 is larger than 2. But just using your number sense, you can figure out that those are the numbers in the set that would work. Okay, this question we already answered. Could it have a solution for part C? We did find the solution was 6. Would 6 be part of the solution set in part D? So what they're asking is, could we say 6 minus 4 is greater than 2? 6 minus 4 is 2. So it would have to say 2 is equal to 2. You can't have 2 is greater than 2. That doesn't make sense, right? If you have $2 and I have $2, we have the same amount. No one has more money. So no, that would not be true. And then how could we change part D, so this question here, so that 6 would be part of the solution? Well, if we had 6 minus 4 is greater than 2. 6 minus 4 is 2. So what we could do then is add the little line underneath our inequality symbol. So we could say 6 minus 4 is greater than or equal to 2. It's not greater than 2, but it is equal to 2. And so that would make our answer legitimate. All right, for part E, it says 1/2 of h equals 8. Well, I know that if I want to solve for h, I need to get rid of that multiplication, right? So I'm going to multiply by 2, because that will eliminate that. Multiply this side by 2, that gives me 16, so we have h equals 16. So 16 times h equals, or I'm sorry, 1/2 times 16, if 16 was h, 1/2 times 16 equals 8. 16 is not in my set of numbers, so there is no solution possible based on these numbers. The solution is 16, so there is a solution possible. It's just not one of my options. And then flip that over here, 1/2 h is greater than or equal to 8. And since I know I'm going to be cutting the number in half, because 1/2 times h, I'm going to look at my biggest number. My biggest number is 14. 14 times 1/2 is going to be 7. 7 is not greater than or equal to 8, so that doesn't count. It can't be 14. And since 14 was my largest number, any other number that I cut in half will actually be smaller than that. So once again, there's no solution possible based on the set of numbers that we have. Okay, we're going to stop there. We'll go through some more examples from this set in class, and we'll look at kind of how we can use this math and how it's going to help us moving forward. If you have any questions, absolutely bring them to me. Thanks for watching, and we'll talk to you very soon.